Hello, I'm going to be going over some examples of the first principle. And I'll start off with, hold on, let me change this mouse size a bit. Three. So, determine the slope of the line tangent to x squared at x equals to 1. Now, previously, we know that given a certain function, we could find another function that gives the tangent lines using this formula here. And we denote this other slope function as f prime at x, and it equals to f at x plus h minus f at x over h limit as h approaches 0. So our goal here is to find f prime at x and then substitute x equals to 1 into f prime at x, right? So let's begin doing that. So we know that f at x plus h would be x plus h squared, and then f at x would just be x squared over h, right? Sorry, I'll make it clearer here. F at x is equal to x squared. And we expand this a bit. The top becomes x squared plus 2xh plus h squared over x squared over h. And then limit as h approaches 0. We notice our x squares cancel out. 2xh plus h squared over h. I'm running out of space on the bottom, so I'm going to go to the right side, and we can actually factor out h on the numerator, we notice, right? So this would equal to a limit as h approaches 0 of h times 2x plus h over h. Our h's cancel out here. And at this point, we could just substitute h is equal to 0, right? Because previously we couldn't do that because we would just get 0 over 0, but now we could just substitute h is equal to 0. This is just equal to 2x, which would equal to f prime at x. And we call this the derivative, and another notation for it would be dy over dx, but I'll dig more into that later on. So we know f prime at x, right? But we want f prime at 1. So all I have to do is substitute 1 into this function here, which would be 2 times 1 equals to 2. So therefore, the slope of our tangent at f at x equals to x squared at x equals to 1 is 2. Now, let me try a different problem. Determine the slope of f at x equals to 3x plus 6 over x at x is equal to 2. Now, this is really, really hard to work with, right? Because if I have f prime at x would equal to f at x plus h minus f at x over h, limit as h approaches 0, I'm going to have a fraction over a fraction, right? So instead, I'm going to do a couple things here. First of all, instead of my function being f at x is equal to 3x plus 6 over x, I'm going to instead write it as 3x over x plus 6 over x, right? These are the same thing. We notice our x's cancel out, so this would just be 3 over 6 plus x. Sorry, 3 plus 6 over x. Now, with this in mind, for my f prime at x, I'm not going to write it as a fraction over a fraction. I'm going to instead drag my h out here. I'll show you. Of 1 over h times f at x plus h minus f at x. And with that, I'll just substitute this again. So f prime at x equals to limit as h approaches 0 of 1 over h of 3 plus 6 over x plus h minus 3 plus 6 over x. And we just distribute the negative in here. So f prime at x would equal to limit as h approaches 0 of 1 over h times 3 minus 3 plus 6 over x plus h plus 6 over x. Our 3's cancel out here. And again, I'm running out of space, so I'm going to move to the right. So limit as h approaches 0 of 1 over h times 6 over x plus h plus 6 over x. Sorry, that's will be a minus here. My apologies. Minus 6 over x, and I'll erase it here as well. And this would then equal to limit as h approaches 0. I'm going to combine these two, right? So this would equal to 1 over h times 6x minus 6 times x plus h over x plus h, like so. And then limit as h approaches 0 of 1 over h of 6x minus 6x minus 6h over x plus h. This would equal to limit, we notice that our x's cancel out here, of 1 over h times negative 6h over x plus h. And you'll notice that h is also canceled out here. And at this point, we could just substitute h is equal to 0 here. And we'll get our derivative would equal to, and sorry, there's supposed to be another x here, and another x here, and another x here. And we'll notice that our f prime, or derivative, would equal to negative 6 over x squared. Now the question asks for the slope of the tangent line at x is equal to 2, so we just substitute f prime at x. We just substitute f prime at x into here, or f prime at 2 would equal to negative 6 over 2 squared, which would equal to negative 3 over 2. And that is our answer. I'm going to do one more example involving a radical. And we are told that f at x is equal to root x. And then find the tangent slope at x is equal to 4. Now, again, we find f prime at x, and then we find f prime at 4. Okay, so f prime at x, we know that is equal to the limit as h approaches 0 of f at x plus h minus f at x over h. This would equal to limit as h approaches 0 of the square root of x plus h minus the square root of x over h. And we would multiply it by the conjugate, right? So this would equal to the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x, right? We had to multiply the numerator and the denominator by the same thing. And we notice that the top becomes a squared minus b squared, right? Equals to a plus b multiplied by a minus b. So this would equal to the square root, or sorry, this would equal to the square root of x plus h squared minus the square root of x squared. And I'm just going to cancel out the roots and the squares here, and this would equal to x plus h minus x over h times the square root of x plus h minus root x. Limit, sorry, this would be plus, as h approaches 0, our x's cancel out here, and this would equal to limit as h approaches 0 of h over h times the square root of x plus h plus root x. And this would equal to, with our h's cancel out here, we have 1 over the square root of x plus h plus root x, limit as h approaches 0. And this would just equal to 1 over root x plus root x, because at this point we could substitute h is equal to 0. This would equal to 1 over 2 root x. Now we want the tangent slope when x is equal to 4. So how do we do that? We just say f prime at x would equal to 1 over 2 root x, and f prime at 4 would equal to 1 over 2 times root 4, which would equal to 1 over 4. And that's it. I hope you learned something. Have a good day.